For the first part of our discussion, we will focus on the negative electrodes that are in the corner of the cell closest to the negative tab. For the second part of our discussion, attention will be focused on the positive tab, between the interface between the positive tab and the welds and the rest of the cell. Our investigation into root cause for the failure of the cells provided by manufacturer A showed that damage to the outermost windings of the negative electrode closest to the negative tab of the cell was the most likely cause for the thermal failures. Through measurement and observation, it was found that the negative electrodes were damaged because the design of the cell pouch did not provide enough room. In the CT images on the right side of this slide, there are arrows that point out the locations of the pouch. The top image is of a cell from manufacturer A. It can be seen that the curvature of the pouch causes it to come in contact with the negative electrodes, causing the electrodes to be bent over. In contrast, the bottom image is of a cell from manufacturer B, showing that the pouch extends well beyond the ends of the negative electrodes and provides enough room. Negative electrode damage like this is undesirable because it can put strain on the separator, causing separator failure and cell faulting. Or it can cause negative active material delamination that can upset the local capacity balance, resulting in plating and potential cell faulting. Cell faulting is a well-known route to the types of thermal failure that were seen in these cells. Exponent's findings related to the thermal failures of cells from manufacturer B showed that manufacturing defects on the welds of the positive tab were able to bridge the space between the positive tab and the neighboring negative electrode, resulting in cell faulting and, in some instances, thermal runaway. The weld defects were related to the height of the features left behind by the ultrasonic welder used to attach the positive tab to the positive electrode current collector. Normal swelling and contraction of the electrodes during charge and discharge forces the weld defect features into the opposing negative electrode. Short circuit between the weld defect feature on the positive tab and the copper of the negative electrode results in heating of the cell. At high states of charge, the cell heating results in thermal runaway.